Hello, this is Mr. Higgins. This is the first video for Unit 1. The title is Relations and Functions. The first thing we are going to cover is some important vocabulary. The first word is relation. A relation is a comparison between two things that can be quantitatively measured. That means that there is a number that can represent how many times that has been measured. A function is a relation for which every input has exactly one output. One of the things that I would like for you to take note of is that within the definition of relation, it does not say anything specifically about it having to be a function. But within the definition of function, it does have something specific about it being a relation. So that means that every relation does not have to be a function, but every function is a relation. Another word that we're going to look at is independent variable. The independent variable is the input. It is usually represented by x. It doesn't mean that x is the only thing that it is represented by, but typically it is. Another thing about the independent variable is that all of its values are what create the domain. It is what the domain consists of. The dependent variable is the output, which is usually represented by y values or by y, and it is what the range consists of. All of the y values are what determine what the range is. Two other words that we will be looking at are discrete function and continuous function. These two particular words are words that we will cover later on in future videos, but just to give you an idea of what they mean, a discrete function is a function that has a break in it, while a continuous function is a function that has no breaks. We also need to understand the multiple representations. Okay, there are 5 different representations. One of them is the graph. Another is the table, mapping, ordered pairs, and equations. Okay, this EQ with a superscript N attached to it is an abbreviation that I will commonly use to represent the word equations. Now in this particular video, the representations that we will be paying close attention to are the graph, table, mapping, and ordered pairs. Distinguishing the difference between relations and functions is something that we are going to have to be able to do. There are 2 possibilities that could come when we're talking about relations. One of those situations is whenever we have 2 independent variables, while the other situation is when we have 1 independent variable and 1 dependent variable. An example of 2 independent variables is when we have the number of people in a house versus the number of TVs. An example of the having 1 independent variable and 1 dependent variable is when we have the number of hours worked versus the pay. Let's consider the first situation. This was whenever we had the number of people versus TVs. The data that has been collected here suggests that one set has 2 people, and those 2 people within that household have 2 TVs. Another set says that 3 people had 6 TVs. Another group that came was 6 people and 2 TVs. Another set was 4 people and 2 TVs. And another set was 3 people and 4 TVs. Now there's something happening here that we need to pay very close attention, and that is this 3 for the number of people that occur here as well as here. Whenever this situation occurs and the 2 y values that are paired up with them are not the same, whenever they are different, this is a relation that is a non-function. It does not satisfy the situation for which every input has exactly one output, because this particular input of 3 has two outputs, one that is 6 and one is 4. So this is a classic representation of a situation when you have two independent variables. One of them does not necessarily determine the other one. The other situation that we were going to look at when we had one independent variable and one dependent variable was when we were considering the amount of hours worked versus pay. Over here in the x, we have 0, 1, 2, 3, and 4, which represent the hours worked, and y, 0, 750, 15, 2250, and 30, which represent the amount earned. So whenever somebody worked 0 hours, they earned $0. When they worked 1 hour, they earned $7.50, and so on. Now notice, none of the x's repeat. Okay? When we have this type of situation, that means that there is no possibility of x having or producing two values. Here, each x produces only one value. So, this is a situation that we would consider to be a function. Okay? The next thing that we're going to do is create some multiple representations of relations and determine if they are functions or if they are not. We are first going to be given a set of order pairs. The order pairs here are -1, 2, 0, 5, 2, 8, and 3, -1. It's crucial that when dealing with order pairs that you understand what the order of the pair is. The first position is always an x, while the second position is always a y. We can take this data, these order pairs, and we can translate them into a table. We usually put the x on the left, the y on the right, and then we pair up our ordered pairs in a table form. So -1, 2, we still have -1, 2, and then 0, 5, 2, 8, 3, -1, and those are all of your x values and all your y values. And be sure to keep the pairs still together. Also, there is a mapping. A mapping is very similar to the table, except that it's in a bubble format, is what I like to think of it as. You got a bubble under the x, which is usually on the left, and you got a bubble on the right, which is usually under the y. And notice all the values that were in your x column of your table are also in your x bubble. All the values in your y column are in your y bubble. And from there, we map the pairs together. The 1 is paired up with the 2. The 0 is paired up with the 5. The 2 is paired up with the 8. And the 3 is paired up with the -1. The graph, the one thing you always have to remember is that we have a horizontal axis, we have a y-axis. The horizontal is always the x. It's always the independent variable, the thing that happens first. The y value is always the thing that happens second. It is the vertical axis. So if we consider the points, we've got 1, -2, 0, 5. Let me change color so you can see that a little better. Whoop, that didn't work. There we go. 1, 2, 0, 5, 2, 8, and 3, -1. Now we were talking earlier about these x's not repeating. They didn't do it in the table, they didn't do it in the mapping, so as well they shouldn't do it in the graph. The tool that we use when determining if x's repeat in a graph is what we call the vertical line test. We take a vertical line, like so, and we drag it across the graph, and we determine if there is ever a point where the vertical line touches 2 points at the same time. And as you can see, as I drag this vertical line over the graph, there is never such a point in this situation. When it satisfies the situation and none of the x's repeat, this is when we have a function. Now we're going to look at another situation. Given the new set of ordered pairs, we have 1, 2, 1, 3, 2, 4, and 2, 5. If you take a look, these have already been moved over into the table format. All of the x values, 1, 1, 2, and 2, they were put into the table, and then their corresponding y values were also put into the table. So 1, 2, 1, 3, 2, 4, and 2, 5. But notice there is something different about the mapping. Previously, we had 4 x values in our table, so we had 4 x values in our mapping. But this particular situation, we only have 2 x values because technically we have 2 x values that repeat. Okay. Whenever we have a situation, whenever it repeats, there's no need to repeat them in the x bubble. But we still have to draw a line from the 1 to the 2, because that's what it's paired up with, as well as the 1 to the 3. And again, we're going to have to do the 2 to the 4, and a line from 2 to the 5. Notice there are 2 arrows coming out of each x in this situation. If we graph these points, there is 1, 2, 1, 3, 2, 4, and 2, 5. Now the vertical line is already here, so we're going to drag it along our graph. And notice, when we get to this situation, it touches 1, 2 times, indicating that our x values have repeated. Okay, that means that there's the same x with 2 different y values. Anytime this occurs, this is when we have a situation that is a non-function. This concludes our video. I want you to be sure to write down any questions you have over the material in the video. You also need to be prepared to discuss why you think a function cannot have repeating x values, as well as why you think the VLT, or the vertical line test, works for determining if a graph is a function. Thank you.